Gonna tell you which ones we got to do. If you don't want to do any of them, A-okay. But I feel like it's wise to use our time wisely. So, anybody got any questions that they were looking at this week and couldn't figure out? What you got? Okay. I'm not just going through. We'll figure it out. Find them.
Okay. It was question number.
Number 14. Inverses. Yep, and this is a tougher inverse, right? Love it. That is a real good question and a hard one. There is already a video on it, so I'll try to do it a little bit differently. We did solve this one. It was the second one they asked. We solved it there. So if you go look online, it's already posted. But we'll do it, and we'll try to do it. And I posted an extra practice problem that's kind of similar but different. So we'll try to do it in a slightly different way. That way maybe there's a little – you can watch both of them if you're still struggling with how to understand it. All right? So really the main purpose of this thing is what is an inverse? Oh, if you need paper, I brought extra paper too. I know most of you have it, but if you find you need paper in the middle of the day, there's a bunch of notebook paper right there. So the purpose of this question would be to ask yourself, well, what the heck is an inverse and how do I even start solving it? I think this one, there were 4 steps that the book gave us to solve an inverse. Step 1 was the super easy one. Not even switching. It was even easier. It's almost unnecessary. But
Writing it down.
Yeah, almost unnecessary. But I mean, we might as well follow the steps. Step 1, right. This is what I didn't do last class, and I'm going to do it this class. Write f of x as y. I'm going to actually say what the steps are. We just kind of went through it. So we might go a little bit slower and see. Okay. Step 2 was a little bit harder. I remember doing green, orange, red or something during class. Step 2 was a little bit more complicated, but not much. Do you remember?
It was switch it.
Was switching it or was it solve first?
Switch it.
I don't remember because and the Wi-Fi's down.
It's working now.
It's working now? Oh, sweet. Okay, I actually really should start this upload then if it is working. 100% sure it says switch before I write it down. What notes would that be from?
99%.
99%? What notes do you think that is? That's day 3 or 4? What do you think? Day 3? I was wrong. Day 5? Is that it? Nope. Day 6? When was inverses? Did we ever learn inverses? 2 point what?
8.
Where's 2.8? Notes? PDF? Oh, there it is. I don't know why it wasn't on the other thing. Okay, so what were our steps then? Just if we're being super careful and going slow, which I think is wise. Oh, they said solve first in this class. Now, when I taught college algebra last year, they had them in out of order. Each book said it slightly different, and it's okay. It doesn't matter. You can switch it first or solve it first. It genuinely doesn't matter. I just was going to be careful and do exactly what this said. So it said solve for x. Solve for x is our next step. So step 2. Step 1 was write it as y. Step 2 is boom, boom. Solve for x. That's the hard step. This is the one that takes math work. So let's get x by itself. Crap. Y equals x minus 3 over 2x plus 5. Any ideas?
Yeah, we can move the 2x plus 5 to the other side.
In parentheses, the whole thing? By move it, you actually mean? multiply both sides by it. But you're right. It technically is moving it. 2x plus 5. But as we do that, we need to make one mental note. And actually not mental, but like we need to make a note. We got 2x plus 5 times y equals x minus 3. And the note has a lot to do with this blue arrows. What's that note? This is a really, really important thought. What note comes from those blue scratch marks? They do cancel out. Something important happens when they cancel out that we can't forget. It might not come into play, but it might. The brain thought process that we have to say is x better not be something. It can be 0.
3.
It can be 3.
-5/2.
X better not be -5/2, which we got from setting the bottom equal to 0. But because we got rid of our bottom, just do the math real quick just so we can prove it. Yep. Because we got rid of our bottom, there's a side note of, wait. Even though we got rid of our bottom, we have to remember in the background, what if we get done with this whole dang problem and the answer ends up being -5/2? It's not, but what if it does? Then we have to be like, hold up. From the start, we said x better not be 5/2, or this is just a bad problem, right? Bad number. A restricted domain. So it's just a side note. Since we got rid of a denominator, our brain has to make a side note saying there was a restriction, even though it doesn't look like there's a restriction anymore now. There still is, that restriction still exists. So this is still all under step 2. Now what?
Multiply.
Yeah, do this little distributive property thing, right? Even though it's backwards, it's still the distributive property. Wait.
This is just a question. Would it be wrong if it? No, I feel like it would just be the same thing, right? It doesn't matter if the y is in front of the.
Not at all. You could have written it the other way too. It means the exact same thing. That is called the commutativity of multiplication. 1 times 2 is the exact same thing as 2 times 1.
This is where I'm stuck.
This is exactly where everybody gets stuck. Because right here is about where I forget what I was trying to do in the first place. What were we even trying to do? It's in yellow up above.
Inverse.
No, that's true.
Solve for x.
Solve for x. That's where we forget because we did so much math that my brain's like, wait, what am I even doing? Oh, getting x by myself. So where are all the x's? There's one right there, right? And there's one right there. I think we got to get them on the same side is the hard thing to recognize. So I'm going to do 2xy minus x equals -3 minus 5y. Everybody okay with that? Or not?
What?
Nah.
Move them to the other side.
Minus x on both sides. Right? And minus 5y on both sides. The x's cancel, right? And the 5y's cancel.
You can do that at the same time.
Yeah, you can do it. Well, yes. You're more than welcome to do it at the same time. I usually do. Heck, I didn't even do it at the same time. I just did it in my head. That's not a nice thing to do, but. Well, crap. We still don't have x by itself.
Divide by.
What's up?
The 2.
Divide by what?
Y.
Divide by y? I'm okay with it. You're allowed to do that. Does that help us get x by itself? Actually, maybe.
It actually kind of does.
It cancels out this y, right? But then we would end up having an x over y on the right side.
It's really not
Factorize what?
factorizing.
Wait, why can't you divide?
2xy minus x.
Like that?
Yes.
That sounds like a smart idea, huh? If you take an x out of there, what are you left with? Okay. And what are you left with on the other side? Same thing? Oh, I think we're one step away.
You gotta get the 2 ways.
How do we get the x by itself?
Divide the other side by 2y minus 1.
Holy smokes. Look at that. X equals negative 3 minus 5y. That's the hard part of this problem. That middle step of just manipulating the math. What's step 3?
You just
Step 3 is switch x and y, right? So we actually end up with all of this, but x's and y's get switched. So that's a y. Boop, boop. Those are both x's. And what's step 4?
there's the
There was a step 4. Yep. F with the little minus 1, x equals all that crap. Okay. I know it's ugly. I'm not trying to pretend like that's the easiest type of problem we have on this test. There are the steps in their order. Here is, I'm coming right back down if you're copying. Hang on one second. Here's an extra practice problem that we went and pulled. This practice problem is actually pretty hard to find. Like we looked for a long time before we could find one. So it's just one, but it's an extra type of the same type. Sorry, it's taking so long. Here's one extra practice problem. Boop, boop, cool. Yeah, that's tough. It's not easy. The practice would be a good thing to go home and practice. And then Google, if you want to just Google around for inverse practice problems, those are good too. Cool? Okay. Somebody said the Wi-Fi was back on, but I don't know if I believe you.
It was on yes.
Oh, guest is working now. Okay, let's see. What's up? Zoom in a tiny bit? Yeah. Okay. Yep. Is that okay? Or even more? Guest is working now. Thank you. Find another problem. Let's hunt down another really hard one. That's a really good example of a hard one because that one takes a little bit of time. More than a lot of the other ones.
Can we just go through like one of the problems in 11 real quick?
One type of problem 11.
I just want to
Sure thing. And if you want to do more than one, we can do more than one. If somebody else is like, well, let's do more. We can.
So I did the first two.
You did the plus and the minus?
Yeah.
Shouldn't be too bad. Did you remember to put parentheses and distribute your minus sign instead of just writing it?
I probably didn't remember that now.
Oh, well, you gotta be careful there. All right, so 11, we've got two functions. We've got a red function and a blue function. And it's really good to keep them like that as we go. All right, so which of these 7 problems do we want to start rolling with? You said just do one, but they're all different. So which one?
Can we do like, no, that was pretty easy. Actually, now I want to see what it looks like. Can we do G?
G? G is pretty tough. Okay, so G technically means G of G of G of X, right? Technically?
Yeah.
Okay. Well, let's just do one step at a time. Literally, like, one layer at a time. What is this orange G of X, technically? That inside orange G of X, what is that? Oh, no. Sure. So we got G of, and this one's orange, right? X minus 3. Okay, stop right there if you have complaint. Because that is the premise of the whole problem. It just gets harder to recognize quickly. That's the premise of the whole problem. Okay, so then hop over to blue. What is g of x minus 3?
Every time you see
Yes,
x,
you plug in.
plug in the equation.
And what's the equation?
X minus 3.
Okay, so we've got g of x minus 3 don't throw that extra x in. That x got switched for the equation.
You don't need that x in.
You just said plug in the equation everywhere you see the x,
Oh,
right?
I did.
Right?
Yeah.
So you're right. It is really tempting because you both said it and first hour said the exact same thing. Said, wait, what about that second x? The one that you were switching out with. You said we're replacing that x with the equation. And you know what we're replacing the next x with? If this whole thing's the red one? The equation. So that's going to look like x minus 3, the orange version, all minus the blue version, all minus the red version. Each step plugged it into the same function. I think we actually had a pretty cool, so there's your equation, which if you work it out is just x minus 9. Minus 3. I mean, you can. We came up with, we were trying to wrestle through that exact problem, and we came up with a pretty cool picture earlier as we were trying to like think about not thinking of it as functions, but thinking of it as shapes or this square right here. And this was pretty much the best, cleanest shape that I could come up with earlier in the day. Let me see it. It looks like a box. It's the same problem. Oh, it's the first one of the day. Right here. That shape is pretty much like, don't worry about the rest of the problem. Every time, instead of you thinking of, see the parentheses x or the quotation mark x? Instead of seeing an x, think about a blank block where you're plugging something into. So the green one, we're plugging in an x to the original function. And then there's another box to plug something in. And then there's another box to plug something in. So the red one, this red x, is the f of, and then we've got a blue f of, and then we've got a green f of x, because x is green in there. That was the last version. And then you close the blue box, and then you close the red box around it. That's kind of, it's like every time you plug the function into the x, every single time. You want to just like, I want to erase it and just look at the innermost function. F of x is that green box. But actually, I think this one was g. Okay, but you get it, hopefully. Yes, to the one we did? Yes. Okay, sorry. Boom. Same exact thing. We just did it without the shapes. Okay, while you look for the next one too, I'm going to freeze this and try to start the upload. All right, find any problem. Find a problem, any problem. Any problem at all. There's no pause button. Back recording. All right, so what was the number of that one, even though we know it's an inverse? Number 13? Use the inverse property to solve. Okay, there's a bunch of ways we can do it. But we'll do the one with the inverse property because earlier in the day, I did it with what we just did. So if you want to go home and practice what we just did a second ago, like 2 problems ago, you can practice what we just did with this. Do these steps, these 4 steps, for either of them, and you should get the other one back, right? Because they're inverses of each other. So you could practice twice doing those 4 steps. But I'm going to practice a third type of way to do this, which is the inverse function property says that f of g of x better be something. Anybody remember what it is? And if not, we'll solve it and see. All right, let's solve. So, what's the outside function?
1 over x minus 2.
Okay. So 1 over big old blank minus 2. And what goes in that big old blank? The next function, right? So Oh, that's amazing. Look what's about to happen. So f of g of x equals this, right? Can we get rid of those parentheses? Yeah, there's nothing happening to them, right? 1 over x plus 2 minus 2. Something really cool happens there.
The 2 and the minus 10.
The 2's turn into a 0, and we got 1 over x. Something else really cool happens there. Keep, change, flip, right? Keep the top. Change division to multiplication. And then flip the bottom fraction. And what's 1 times x over 1? Just x. So the inverse function property says that stuff better be x. If you want to practice, you know what you could practice to see if it works out really nice? Do it backwards. Do g of f of x. We won't do it right now, but you can go home and practice it. That's a good way to see, oh, do I know what we're doing or not? But that proves it. Proved. They're inverses. If you want to go watch us do the actual inverse process, go watch the other video or earlier in the video because we did the actual inverse process, which is what we just did for question 1. Switching x and y, solving for x, getting your problem. For the sake of doing more variety of problems and not spending 20 minutes on the same problem twice, we'll leave it there. Okay. Yeah, but this is a good one to go home and practice because it's the same thing, just flip-floppy. This is the inner function now. You change what the inside function is. All right, what else we got? Other types of...
8.
Number 8 is...
Oh, wait, no, it's
No.
graphic.
Yeah, and it's not even... But it's also not even graphing. It's just saying the words. Okay, we can do number 8 real quick and not even write it. I'm not going to copy and paste. How do you obtain that graph? There's like 4... You can say it in 4 words probably. I think it's... Yeah, 4 words you could say it. Oh, no.
Say what?
I think it's a 4-word answer. I mean, obviously you should write more than 4 words on your test. But I'm saying the essence of it comes down to 4 words. Up to, write 3.
Oh, so we just say, how do we get... Oh, we're just explaining. I get it.
What were you about to say? How do we get?
No, whatever.
Yeah, I was going to be mean and say, what does obtained mean? But obtained means get. So yeah, it is just saying, how do you get it? How do you get that from that? You up to, remember the middle's flip-flopped, right?
Yeah.
Write 3.
So, right.
But maybe write more words than that. You could call it a horizontal shift to the right of 3 and a vertical shift up 2. Cool? Okay. That's a gimme. Take that one and run with it. If you get that on a test, that's amazing. Same with number 9. Number 9's a gimme too. It's the same question. How do you get this? It looks like a horizontal reflection. That's the answer. You're done. All right. Good question. The words are not always as fun as like just working it out. Because that's just a straight memory, really. Not even a mathy. What else we got?
I'm thinking 19.
Number 19. And if anybody else wants to ask,
Yeah, no, we
yell what you want. Oh, frick. Man. Okay. Yeah, we can do it.
Why just say...
We just spent a long time doing it before. So you're definitely allowed to go watch the video. But for the people that won't do that, let's do kind of a quick version. Not even quick, but just a review version. What is the essence of this problem? We've actually done this problem, and we did it in class with real things.
We threw the thing.
Yeah, this is literally just throw a thing, right? A cannonball's fired, and it follows that path. I give you the equation, which is super nice. You don't have to find the equation like you did with the other thing. And they want max height, and they want horizontal travel. That's exactly what we wanted to. Or no, that's not what we wanted. That's what we measured. And we found the formula. Here they're giving us the formula, and we're going to try to find the things. So what does that function look like? What is this shape is the important thing. It's definitely a shape. Oh no.
Because of the, I mean,
Scary.
because it says, wait, what do you mean?
What shape is it?
Like on the graph?
Yeah.
Oh, because it says the x squared.
Yeah. Oh, yes. The x squared is what makes it a parabola. What else do we know about the graph? Give you a hint. This means something.
Oh, there.
That means it's like this, right, Sad?
Yeah.
Open downward. Yeah, open downward is no. Open downwards is a better way to say it. I just don't say it ever. But you're right. No, you're right. Open downward is a much better way to say it. I think that's all we know right now. So here's our parabola. I could have drawn it back. Actually, I'm not going to draw it yet. Don't draw it yet. We don't know what it looks like. How are we going to find the max height? That's exactly what we're going to find. What'd you say? We got to find the vertex. But how are we going to find the vertex? You have it memorized. I knew this was going to happen, and we said this. Yeah. Uh-huh. And even if you didn't have it memorized, you had it memorized without knowing you had it memorized, right? Because you had the quadratic formula memorized. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And where is it? It's hiding right there, right? There. If you forget your vertex, it's hiding right there in the quadratic formula. You don't need paper, but if you want it. We're just doing the review. But you can take it if you need more paper.
Okay, so
Okay. So that's the vertex, negative b over 2a. So what is negative b over 2a in this case? Got to be super duper careful.
yeah, because they're opposite. Like,
Because they flipped them on us, right? Technically, that we should write it better. Should be negative 0.01x squared plus 10x plus what? And then we got an A, right? A B, and a C. We don't need the C for this formula. So what's our negative B over 2A?
negative 10 over 2 times the negative 0.01.
Okay, this is where it'd be calculator part on the test. Now, if you don't bring a calculator because you forget, you can do this without one. It's a little harder, but you can do it. But this is where we would jump out and grab a calculator. If you weren't here earlier when you walked in, the calculator that you really need to get, if you want the cheapest one that does all the stuff you need, this is it. $8, $9, Walmart, H-E-B, Target. Okay.
Actually, this is pretty cheap.
How much is that?
Like $8.
Okay, so do the same thing. Actually, freaking, they're probably the same name. What is the name of the top right of yours?
Cassia.
Oh, TI? No,
Cassia.
30? It doesn't say 30 on it? Oh, okay, fine. You can buy that one for $8 too. What else are we doing? So what'd you say it was?
Negative 0.05.
What? I feel like it's supposed to be like 500 or something. Is it supposed to be 500?
That's $8.
Oh, I didn't do that.
I said $8. Very good, very good. What is that 500? Scary question that is.
It's just a point.
It's.
Part of the point.
Yes. Which part? Left. The x. The 500 is the x value of the vertex. And how do we find the y? You plug it in. And if you plug that in, what is it H or is it F or what? H? What do you think H stands for? Guess what H stands for? Height of the ball or height of the cannonball, probably. They always do that. H of 500. I won't do this. I'll let y'all do this in your calculators. That way you can practice typing. I think I remember it. The other way to do this is completing the square. Don't do that. This is way easier than completing the square, I believe. The height of 500 is when the cannonball has flown 500 feet, it reaches a height of calculator. Plug in your calculator. I don't have.
Saying another number.
I don't have a cal. No, please say another number. Who cares? People get stuff wrong all the time. Doesn't matter. I get stuff wrong. How many times do I freaking mess up? And sometimes I don't even catch it. And someone will tell me the next day.
2,500.
250? Or is it 2,500? Can I get an amen? Okay. I don't know why my brain remembers 250. It's scary. Maybe I messed up earlier. So I know that's a lot of like weird work looking together. So what is that? What is that? Yes. So what is that? What is this? For the people watching the video, I asked, what is this? Mm-hmm. It is. And how do you write it better? That is an equation representing the vertex. So if we wanted to write it as the vertex, we would write 500, comma. But to better answer the question, what's the answer to the question they asked? So what is the max height? Mm-hmm. And if they ask, where does the max height happen? You'd say 500 feet after launch. That's the max height. Love it. What a fun question. So here's a cool thought. Vertex is technically HK, but there's a better way to write the vertex that's easy to, or not easy, but always rememberable. Let's write the vertex in a form that's perfect every time, always works. What's the x value of the vertex? The x value, if this is the vertex, we're going to write the vertex in a form that we can always remember it, hopefully, and not have to remember all these steps. What's the x value of the vertex? Not for this one. I'm talking for everyone ever. Negative b over 2a. And what is the y value of the vertex? F of that stuff, right? That's a cool way to remember the vertex instead of just HK. HK is just random. Who knows what HK means? That doesn't help me solve it. This helps me solve it, right? Now, granted, the vertex is always called H comma K. Like, we've seen that before, right? That's a thing. That's not as helpful as this. This left thing is way more helpful. Okay. So we've answered question 1. Now we've got to decide, how far does the cannonball travel horizontally before splashing in the water? What the heck? How far does it travel horizontally? So here we go. Here's our cannonball, right? They shoot it up. How high does it go? Where does it go 2,500 at? At the point 500? So how far do you think it goes? Just had to guess.
What do you mean? Oh,
How?
I'm gonna go 1,000.
Why 1,000?
Because that looks like it's the middle. I don't know.
Is the vertex in the middle?
No, it's 1,000.
Is the vertex in the middle then? Is the question to ask ourselves. We got to prove this or not. Why do you think it's in the middle?
Because it looks like that.
Because it looks like that is a good answer. Let's prove it. What are these? These things have names. Let's make them green. These green dots have names. They're called zeros. How do you solve for a 0? How do we solve for a 0?
Isn't it like x equals whatever?
You take the equation and you set it equal to 0. I've forgotten the equation at this point. What's the equation?
Oh, 10x minus 0.01x squared.
Equals, you take the equation and you set it equal to 0, right? And then we solve. How do we solve this thing? Actually, one thing we should do first, because it looks easy. Let's yank out an x. What are you left with? 10 minus 0.01x. Now, how do you solve for zeros at this point? Oh, this is what we've been doing in class. This is what we've literally been doing with the division. No, it doesn't. How do you solve that? Just because it's got a decimal? How do you solve freaking polynomials? You would literally know exactly what to do if we had this.
Yeah.
No, it's the exact same thing. It's the exact same thing. Well, how do you solve that? Actually, you probably don't even know how. You just like, our brain, not you, us all, our brains just jump to the right answer, right? Our brains just jump to that sometimes, right? Because like, oh yeah, I know the answer is -2 and 1. How did you do that? Don't say it. You're right, but don't say it. The inside of what? Which one? Okay, and then what about on the other side? Okay, so let's do the blue one first then. Let's set the blue thing equal to 0. Let's set the blue thing equal to 0 and solve. What do you get? Does that make sense that that's one of those zeros on that picture?
Yeah, that does.
It does, doesn't it? Okay, let's solve the other one. Let's solve the black one. 10 minus 0.01x equals 0. Any ideas?
Plus 10. I mean, minus 10. No?
Well, yeah. Fine. We'll do it this way. Well, no, we will. It just takes one extra divide by -1. Divide by -0.01.
Yeah.
Divide by -0.01. Here's where it's time for the calculator, right? So x equals what? Do that in the calculator real quick. -10 divided by -0.001. I said it wrong. -0.01. Was it what we thought it was going to be?
Yeah.
It was 1,000?
Yep.
Dope. That was a good guess then.
It wasn't a guess, it was a guess.
Yeah, right. But some people guess a different number just because instincts are not always perfect. Okay. There we go. We know how far it traveled. We know how high it went based on an equation. All right. Hunt down a different problem. I'll zoom in and leave it there while you find one.
Wait, can you repeat why you changed the signs in the second equation?
Yes.
No, like go up,
Yes.
up.
Okay.
Yeah, H. Wait, put it, yeah.
Right there?
Yeah.
Okay, I didn't necessarily change the signs. And I just moved what order we wrote them. There's technically an invisible plus sign right there, that green sign. So it stayed with it, yeah. It's in the simpler form for anyone else. In a simpler form, what we did is -2 plus 1 is the same thing as 1 minus 2. If you want to call that equals f of x, even though it's not really a function. But those are the same thing. You're allowed to move them. Joop, joop, joop. You keep whatever's in front of it with it. And whatever's behind it doesn't matter at all. Cool? Yeah. All right, what else? Hunt down more problems. We don't have a lot of time. We actually do. What you thinking? Number 18? What's it looking like? 18's looking like... Oh, dope. We haven't done the one of the, or this is the first one we didn't do last class. So this is great. But however, this is the exact thing we just did on that problem. So this is good practice. I'm going to put it at the bottom of this because it's like genuinely the exact same way to solve it. Going to be a different answer, but the way to solve it is perfectly the same. Find the max or the min. Here's a function. Cool?
So funny.
Well, we're going to zoom in. Find the max or the min. Here's a function. Y'all ready? Well, let's identify first. Does it have a max or a min? Max/min. I don't know. You tell me. They said max. Now they're saying min. Well, those are the only two options. So you're definitely right.
The first number, right?
The first number matters.
Yeah, because
It's
so
positive, so it's max.
It's positive. This is positive, right? That means it is. If I'm positive today, that means I'm happy.
which means it has been.
And that means there's a bottom point, like a trench, like the Marianas Trench. So this has a
I
min.
guess we confuse sometimes. Like I think happy max.
I know. That's why I always like to go highlight, write the plus, write that every time.
So it has a min?
Absolutely. Because it's a happy parabola, because it's got a positive first term. No other term mattered. Only the highlighted term mattered for whether it was max or min.
Okay.
Okay. So we're halfway done. And I'm pretty sure the test says, like, does it have a max or min? Circle one. And then it says find it. So there's half the points right there if you can just do that. That's important. Second half is what we just did with the other one. How do we find where that minimum is? It's got a name. You just got to find the vertex. All right. How do you find the vertex? 100% negative b over 2a. Which in this case is 2 times 2, which is negative 3 over 2. That's not a vertex. That's an x coordinate for, oh, this is going to suck.
We have to put that.
You have to- Yeah, it's not going to suck that bad, but we do need to go plug
You
it.
have a calculator, right?
I don't know. Well, it's not going to be, I don't know. I don't know if this would end up there or not, but let's do it like it would end up there. Let's do it like this is by hand. You should be able to add and subtract fractions. I'm sorry. I know that it's not fun, but it's an important skill. So g of negative 3 over 2 equals 2 times negative 3 over 2 squared plus 6 times negative 3 over 2 plus 3. Yeah? Just plug it in to where you see the x. That's plug and chug. That's the day one. That's that machine diagram. That's that input output. That's that domain range. Let's take an x, turn it into a y. And now we have to do the other stuff that we never taught in this class. We just assumed you knew how to do. And we'll just keep reviewing it forever. PIMDOS tells us to do parentheses first. Can we do anything inside of these parentheses? Nope. Can we do anything inside of these parentheses? Nope. So what comes after parentheses? Oh, crap. PIMDOS is important.
Oh, yeah.
PIMDOS. Parentheses, check. There was nothing we could do. Exponents, there's only one, and I think we should do it. 2 times. What happens there? Negative 3 over 2 squared. You know, multiply by itself? We'll go do that off to the side. Negative 3 over 2 times negative 3 over 2. Multiply the tops and you get. Multiply the bottom and you get. There's your fraction. 9 over 4. Just multiply them by each other. You're allowed to go off to the side and do it if you don't like doing it in your brain. 6 times negative 13 over 2 is negative 18 over 2. Right? Plus 3. 2 times 9 is 18 over 4
Negative.
minus 18 over 2 plus 3. Let's get a common denominator. Actually, 18 over 2 reduces.
9.
Thank you. That's multiplication tables there. 2 times 9 is 18. 9 and 3 combine. Negative 6. Whoops, not equals. Minus 6. And now, we could just leave it there if you were taking a test. But if you wanted to get a common denominator, 24 over 4. 18 minus 24 over 4 is freaking negative 6? No. Yeah? So negative 6 over 4. Negative 3 over 2. What a mess. Oh, holy crap.
Wait.
That's pretty cool. That's how you know you probably got the right answer then. Because it just works out nice and neat. That's pretty cool, though. So what's your vertex? What a cool vertex. And what's your minimum there? I guess. But it's this one. But it's this one. But I guess it's easy on that one. Okay. You're right. Hopefully the test won't have the fraction stuff. Chances are it's not there. I don't think it is. I'll work it before, make sure. If it is, I'll let you know. If it is, as you're working, I'll be like, hey, number 4 is fraction, and it sucks. But be aware of that as you go. All right. Hunt down more. We've now reached the 1 hour left mark. What? We've only done 3 problems? Oh, nice. Dibs. Okay. Not a problem. Look at the papers. Look online if you don't have the papers. YouTube's up, which means the website should link you to it. Let's check and see. Rico, what's up? You got one?
No, it's from the previous question, but if you want to find the max, is it still going to be negative 3 over 2?
Yep. Your vertex is always that. Same process to find the vertex. Don't even add a negative or positive. Nothing changes. Exact same system. Finds you the vertex. And your max is always the y value. And sometimes, I don't think it's going to show up, but in math, they'll call the x value the location. The location of the vertex is the x value. The vertex is both. The height, or max or min, is the y. Location is where it occurs. The value is what the number is. All right. Can we do 12b? Sure. Oh, that's amazing. What a great problem. We can do both of them real quick. We'll do both of them only because first hour didn't do both of them. So if some of them had this question and didn't get to ask it, then they'll be able to see it as well. Holy crap. How do we know if something's 1-to-1? Yep, that's right. What is it called? 1-to-1 means horizontal line test.
Oh, 1-to-1.
What does vertical line test mean?
To find a function. If it's a function.
Absolutely. Function or not. Okay? Horizontal line test works for that. Vertical line test works for that. There's another way to determine whether it's 1-to-1. That's one way. Great. There's a second way. Inverse. Can you invert it? And then the real question with that inverse is there a plus and minus? Is there a plus and minus? Because if so, bad. But the first way is the easier way. So let's start with A. We've got f of x equals x3 plus 1. This kind of comes down to, do you know your parent functions or not? which I'm sorry that that's a question, but what does the cubic parent function look like?
This.
Like that? Is that function alone passing this horizontal line test?
Yes.
Looks like it, right? Okay, so it gets a check mark 1-to-1. But that's not what it asks us. It asks us for the same function, shifted up 1. So that same function, is it also going to pass? Absolutely. So it's also a check. Yes, 1-to-1. I know you knew that already, but just worth doing. Okay, so the same thing here. This comes down to knowing parent functions, unfortunately. G of x, what's the parent function for the absolute value? It looks like what?
Like the V.
Looks like a perfect V, right? Okay. Does that pass the horizontal line test? That 2 bad spots right there, right? So the original parent is not 1-to-1. Okay, so the parent is just I know there's a bunch of notes. Is not. This is just what you would think as you do your brain process. The parent's not 1-to-1. Same thing here. The parent was 1-to-1, right? Parent is 1-to-1. So was the red thing after it. The parent's not 1-to-1. But what was the transform they actually gave us?
They told us to go.
Careful. Yeah, what is that transform? Be really careful. Think before you answer.
Go left.
Left 1. Why left and not up?
Because it's in the parentheses.
Because it's inside the thing, right? So let's shift this thing. Though, actually, it wouldn't matter for our answer to the question. If you went up or to the left, the answer is the same, right? But, I don't know. If you were answering a different question, it going to the left 1, does it still not pass? Not 1-to-1. So the crux of this problem really came down to, did you know the parent functions? Not necessarily did you know how to invert it or do a math formula. It's did you know the parent functions? Go from there. Which there are really, I think there's like 5 parent functions you should know. Remember we said we're not messing with that step 1 ever pretty much, even though it's in the book and it's worth knowing. There's line. What's the line parent? Oh no. This is like 3rd grade.
Isn't that just X? Like,
It's not just X. It's what? It's not it.
It's not.
You're dancing around it. What is it? Y equals X. It's important.
Oh, okay. What?
Or f of x equals x. Same thing, right? All right, parabola. Y equals x squared. Little squiggly snake looking thing.
X.
Y equals x cubed. Y equals x4 looks almost exactly like it, right? It's just a little squat. That's bad. It looks almost exactly like the parabola. It's just a little wider at the bottom. And the x to the 5th is the same thing. Y equals x5. Looks almost exactly like the 3. It just goes out a little longer before it does its stuff. Okay, there's a couple more. Absolute value we need to know, right? Looks like that. That's y equals absolute value of x. And also the root is a good one too, right? And that might be it. Oh, what happened? You see what else got disappeared? Oh, this arrow. Y equals root x looks like what?
The thing like this.
You know, sideways parabola. And that's it for now. Eventually we'll do y equals 1 over x. Fun foreshadowing into the future. But we haven't done that yet. All right. Sorry, that's a side note on just parent functions, but good for everybody to remember that is part of what we need to know. Add page. What else we got? All right, hunt down some problems. We don't have all the time in the world. We have 50 minutes left. If you need to leave, use the restroom, come back, feel free, but we'll keep rolling. 16? Sure thing. Oh, yes, thank you. Nobody did this one either. This is great that we're covering some ground that wasn't already covered. Okay, 16. Oh, wait, I'll just leave it big. Ooh, interesting. I'm trying to decide whether we should do an arrow or not. No.
No.
No? It doesn't give us an arrow. If it doesn't give you an arrow on a test, don't pretend there's an arrow there. But usually on a test, there'll be a dot if it's there. This is just out of the book. I don't know why. All right, so we're going to pretend like there's no arrow there. Actually, can we pretend like there's an open dot on one of those just for practice so we see everything? Let's do an open dot, just so we see every type of problem. So let's do open dot on the y-axis. Yeah, nothing. That doesn't affect anything else here. Oh, no, it does, because f of 0. Crap. I tried to be cool. Screw it. We'll do not. But you would know how to write it if it was an open dot in terms of domain and range. Curved bracket instead of regular. All right, just for doing all the problems, we're going to leave it closed. Find the domain and range. Domain is x. Where does it start?
It starts at 0.
Careful.
0?
Careful.
It literally starts at 0.
Okay, good. Make sure. And it includes it because. And where does x end at?
It ends at
1, 2, 3, 4, 5, 6. Looks like 6. It ends right there, and it includes it because we counted from that red one to that red one, right? Technically, if you want to visualize your domain, it's that red little thing at the bottom. I'll switch to blue for range.
1, 6.
Your range starts right here, right? And it goes up to here. And if you want to visualize it, it looks kind of like that, doesn't it? 1 to 6. What's up?
So we're putting those brackets because there's like circles.
We're putting the brackets because they're complete circles.
Okay.
We would do the curvy ones if they were open, which is what I was going to try to do. But then I realized it would screw up part B. It would make part B an undefined answer, so I just said we'll leave it. All right, so that's part A. Pretty much done. Part B. Find f of 0.
1.
You just look at where is this function when x is equal to 0. You get 1. Here's the question of the year so far, which is really more struggle than it should be. I shouldn't even have to ask the question. What? No question. What is that?
A function.
Y'all, I can't even count the number of times. It's okay. We have to look at that and immediately think something. Well, maybe, but it might be. I don't know what f is. It might be. No, it's not, because that'd be equal to 0. Well, no, that is just a very simple thing. Yes, that's what it is. What is this?
Coordinate.
It's a coordinate. What are the coordinates? Careful.
0.
Oh, x is there, so 0.
What does a function do? It takes x's and turns them into y's. It takes a bunch of x's and turns them into a bunch of y's. In this case, it took one specific x called 0 and turned it into one specific y called 1. And then if we mash that x and that y together, we get the classic thing that's called a point. Now, I don't think that's what it asks us for, but every time you see that, you should think, oh, that point's probably on there. And by golly, it is. So, f of 4 equals 1, 2, 3, 4. Looks like 4, 3. So 3, which is the point 4, 3. Man, they're giving us tons to do. I'm going to run out of room on this graph. Wait. No, we're good. I'm just going to go get it again. That way I can do the shift on not the same thing and make it really ugly. What problem is this?
16.
There it is. I'm just grabbing the graph again. Oh, I already had it. Oh, am I wrong?
No, I
Yeah, it looks like it, doesn't it? Someone else. How do you get f of 4?
You look where 4 is, and then
Look where 4 is.
on the X,
Thank you.
And then you look at the Y.
You look for 4 is on the x, and then you check for the y, because the red line is the function that takes a bunch of x's and turns them into specific y's. Yep. Okay. I'm just gonna use this a couple times. Boop, boop. Okay. So what's it saying to do? Graph a couple of for part C. It says graph. What is the first shift happening?
To the right, to
And what's the second shift?
up,
And it said just graph those. So I copied some new graphs so we could do that. To the right two. Just take each point and go to the right two. That's all we're gonna do. Right? Take each point and go how far? Stop this. Take each point and go how far up are we going to go? Up to? Stop. There's our two shifts. Okay? Find the net change and average rate of change.
sorry.
Look at this. Look at this. Have it.
Oh my.
Oh my.
How much points is it again?
It's not points anymore. It's about to be like freaking points off. That's what it's about to be, actually. Holy crap. We're some like sixth graders. Oh. What a waste. Yeah. Put it up. Saw you. Yeah. For me. All right. Let's get this going. What are we doing here? What's the next thing we're doing? Net change? Everybody remember that formula for net change?
FB minus FN
Mm-hmm.
over.
Nope.
We're not over?
Net change is FB minus FA.
Oh, there's nothing else.
What's the other formula?
Average rate of change.
Yeah.
That confused me.
Same thing. FB minus FA over what? Mm-hmm. B minus A.
Oh, okay.
Okay? So, whoa. They're saying to do it for 2 and 6. Well, what do we need to know if we're going to do 2 and 6? We probably need to know f of 2 and f of 6. So what's f of 2 here? F of 2 looks like 2, doesn't it? And what's f of 6 look like? 1, 2, 3, 4, 5, 6. Oh, crap. 1, 2, 3, 4, 5, 6, 7. Good call. 7. So what do we do with those 4 numbers?
You plug them
To what?
to your third.
So for net change, what do you get?
You're going to get F.
Yeah, but we already did it. We already did it. What's f of b? 7 minus, and we get
5.
an average rate of change. 7 minus 2 over 6 minus 2, and that's going to give us
5 over.
4. Our net change is different than our average rate of change. Net change is the total numbers that y changed. Wait. Yeah. Yeah, it's the same thing. I'll just make sure. Yeah, no, you could do y2 minus y1. But here's your x's, right? You're going to call that x1, x2. Here's your y's, y1, y2. Go to town. Golly, we're really, there's a bunch of problems associated with this one problem. Find the inverse of 1. Now, this one might be a little sneakier. Find the inverse of 1. What does inverse mean? Yes. So what is this usually? If inverse means the opposite, what's usually inside of here?
Just
We're asking ourselves, what is usually inside the parentheses now?
negative.
-1's usually inside the
I don't know,
parentheses.
you said opposite.
What's usually inside the parentheses? X is usually inside the parentheses, right? So what is that -1 then? It's your y now. If x is usually inside, because we're doing the inverse, that's your y value. Because it's inverses switch x and y. 3 is your y value. Okay? So where is the y value 1?
0.
There's your answer. Don't overthink it. Do I have any room to do E down here? Yeah. E. F invert 1 is 0. Because we switched x and y. That's not a point. That is not a point. That is the backwards of a point, because inverse means backwards. That is the backwards of the point 0, 1, right? It is a point on the graph, inverse graph, but it's not a point on our graph.
That's the only way to find it.
When you have a graph, yes. If you had the function, you'd have to do what we did earlier. Switch x and y, solve for x, plug in a number. That's the only way to find it there. But we don't have a function. We don't know the name. We don't know the numbers for this function. So the only way to find it is to go and look at the graph for that number. So this one says, where is y3? Where's y3? Hop over to the graph. Go to the 3. Go all the way over. Looks like it's 3 at
4.
X equals 4. So invert of 3 is 4. Inverting stuff is cool though, because you can just take whatever point and switch them. So, and then I think the last thing they say to do is, hey, can you graph it? So watch this. And then this graph would actually answer that last question for us. But you just take each point and flip it. So what is this point right here? That point is 0, 1. So what is the flip of it? It's on the inverse. Let's make our inverse like a really bold color like pink or something so we know it's the inverse. F of -1 is our inverse. Cool? So, whoa, don't do that. So what point is on our inverse? If 0, 1's on our normal, what point's on our inverse? 1, 0, because they're the flip. Pick another point that's on our function. 3, 4? So what point is on the inverse? Wait. I messed up. That point is 4, 3. The 3, 4 will be on the inverse. That point is 4, 3 though, right? So what point gets on the inverse? The point 3, 4, which is right there. Okay, pick another point that's on our normal function. Any point in the world. There's only like 3 more nice, neat points. Say 2, 2?
Is it not 6?
Wait, 2, 2. Flip it. So guess where the point on the inverse is? The same spot. Holy crap. Because 2, 2, where you switch x and y, is on both. That's pretty cool, I think. Maybe you don't. I don't know. Pick another point that's good.
5, 5.
Is 5, 5 on here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, dope. So that's kind of like 2, 2, huh? And last but not least,
6, 6. No, not 6.
I think that's not 6, 6. I think that is
7, right?
6, 7, which means the point. Oh no, I've made a terrible mistake.
Your color.
Also, this one was wrong too. 5, 5. What's that top point again? 6, 7, you said?
Yeah.
6, 7, which means the point, what is on our inverse? Is that right there? No. It's right there? Cool. So we connect the dots with a pink line. Connect these dots. Oh, look at that. They worked out as a line. Connect these. Oh, look at that. They worked out as a line. Yeah. Yes.
20, is it supposed to be a square?
Yes, definitely. But if you can graph the line, good too. If you can graph the normal line, which is just combine like terms and do the line, also in the scope of what we've learned. Wait, but there's something really cool here before we move on. Anybody see something really cool that we actually did learn about how to graph an inverse? What does it look like happened?
It just flipped.
Flipped over what? Reflected across what? Didn't it reflect? That would be like this, right?
Yeah, no.
What did it reflect across? We did learn this at one point. And you're right, it did reflect. It just reflected across a really specific thing. Watch this. Well, that's too skinny of a line. It reflected across a specific line. Watch this line. Ugh, I hate this. Watch this line. What line is that?
Oh, we have the line for the.
Bless you, bless you. We already did it once today.
Isn't that like fx of x?
F of x equals? Boom. That's how you find the inverses. You reflected across that line. Which makes sense because that's the line where you switch x and y. X and y are the same there. It's pretty freaking cool, I think. Next one. That's a long one, but that's a good one to practice. I might have to go hunt down a properties of a graph. Is that what that would be called? I'm going to hunt one down while y'all do that to post to practice. Yeah, that's not it. Nope. Haha, that's it. Sweet. All right, hunt down two more problems while I copy and paste these. We got 30 minutes, so we could probably power through like a bunch of problems. Right underneath what we just did, I'm posting more of like very similar graphy problems. So if you want to go home and practice that exact type of problem, this is a pretty good way to do it. Is just go and practice these right here. Boom. Practice problems posted. All right, anybody find a good practice? No?
Number 6.
For sure. Oh, heck yeah. Good job, y'all, at picking ones that weren't already done. All right. What's number 6 looking like? One of these functions is linear. Which one's is linear and which one's not? I guess you just have to know what linear means. What does linear mean? Kind of means the word line. What's the normalist function for a line? Y equals x. Which one of those looks the most like that? Sure, linear. What's the opposing word for this one, for f of x? It is nonlinear, you're right. But it also starts with a Q. Yes. And sometimes it starts with a P if you want to call it that. Parabola, right? So linear functions make a line. quadratic functions make a parabola. Cool? So that's the answer to A. Sketch a graph of each? Fine. I mean, it's okay. I just don't want to. Boom, boom. Anybody got a handle on what the normal parabola looks like? Let's not call it f of x. I'm going to call it freaking, I don't know, a of x. I don't know. A is weird. No, there's already a g in the problem. H. P for parabola. P of x equals x squared. What does that look like? Like that? Okay. If you had the numbers, it'd be really good to use the numbers. If you had the numbers, you'd have the point 1, 1 on there. And you'd probably have the point 2, 4 on there. Cool. And so on if you had lines. But what does that blue thing do to it? F of x is not that. F of x is parentheses x plus 5 squared. That's a shift. That's a left 5 shift. So we're going to take the exact same parabola and go 1, 2, 3, 4, 5. Dot. And just shift it. Sketch a graph of each function. That's the blue graph. You got to do the same thing for the line. What's the normalist line look like? The normalist line just looks like that. Call that L of x equals x. Which means g of x is the same. Oh, g of x has three transformations. Holy crap. G of x is almost easier to just plot 2 points and draw the line, right? Like, pick any 2 points, plot them, draw the line. That makes your life easier. Let's do the transformations too, though. What's the transformation happening to g of x? Up 1. Right? That's a reflection? Vertical reflection. And 5 is a vertical stretch. That's harder than just plotting 2 points, right? Like, what's the point of that? But watch, let's do it. I'm going to do it just for fun. Vertical stretch, it makes it steeper. Cool. Flip it, makes it flip. Erase the first one. Up 1 makes it go up 1, where that's just one space right there, even though it looks big. Okay? Let's plot 2 points instead. Pick a random point, even if it's an easy one. What number is the easy ones to plot? Sure. What's g of 0? 1 minus 5 times 0 is 1. Does that point look like the point 0, 1? Sure thing. It does to me. All right, pick one more point, and then we're done with the graphing. G of 2?
Yeah.
2? G of 2 equals 1 minus 5 times 2. That equals 1 minus 10 equals negative 9. That's 1 and that's 2. Does that look like it could be negative 9? Sure. I don't know where it is. Oh, 1's actually probably not even the intersect. I bet it's actually like way over here, for being honest. But you don't need to do that. You just need to plot 2 points and graph them. 2, negative 9. And you've got your line. Or you could do the whole slope thing. Plot the y-intercept and go down 5 over 1, down 5 over 1, down 5 over 1, rise over run. So many ways to plot a linear function. There's not just one. Or you could just plot the 5 main points that we always plot. Negative 2, negative 1, 0, 1, 2. Draw the line. So many ways to plot the line. I don't want to do them all, waste our time, but maybe go home and practice those all the different ways and see. Oh my gosh, there's a lot of problems here. What's the rate of change of the linear function? So that means you had to know which one the line was. What does the rate of change mean? There's a bunch.
The formula?
No, it's actually asking for the actual rate of change. That's exactly what that means. Slope. And what is the slope? Rise over run? And what is the rise over run of that line? Rats. Well, if we don't know, you got to plug in points then. If you don't know, you just plug in some points. Let's find out. Pick a point. Pick a point. What? What? Pick a point. 1? Plug in 1. See what you get. What's g of 1? 1 minus 5 times 1 equals negative 4? Okay. I don't know why I put parentheses. So what's the point there? 1 comma 4? Pick another point. 2? 1 minus 5 times 2 is negative 9. It's got 2 comma negative 9. What's the formula for rate of change? Okay, so pick your y2, pick your y1.
-9.
Minus negative 4 over 2 minus 1 equals negative 9 plus 4 over 2 minus 1. You're going to shoot yourself in the foot now. Equals, what is that? What's your rate of change? What's your slope? Yeah. Always, right? Mx plus b. It's the m on mx plus b. You don't have to plug numbers in. You can just look at it and say y equals mx plus b. It's the thing attached to the x. Every time. Y equals m. You've heard y equals mx plus b before? Okay. It's just backwards. They wrote it backwards to try to trick you. They did y equals b plus mx. And determine and simplify a composite function. We've already done 2 of those. We can do another one, I guess. F of g of x is the same thing as f of g of x, right? What is g of x here? I don't know. Somebody read g of x for me. Okay.
1 minus 5.
Thank you. 1 minus 5x? Now, what do I do with that 1 minus 5x? No, I don't think so.
No?
I don't think so.
Plug it in on that. Or
Where? Everywhere you see an x. So what is the normal f of x? I don't remember it.
I can't see it.
You have to look at it.
I don't have it.
Oh, that's right. I gave it to you. I gave it to you, right? Gave it to you like a week ago.
Oh, I don't know.
Okay.
X plus 5 squared.
X plus 5 squared. So everywhere you see an x, you plug in that red thing, right? So we've got 1 minus 5x. That's your x. That's your x, right? But you said it was x what? Plus 5 squared? There you go. There's your red is your function. Red is your f of x. You're plugging in the thing from the inside. It's like a dream within a dream, like if you see an Inception. So this is technically big old parentheses. I'll do it in regular. Big old parentheses, small parentheses, boom, plus 5, all squared. Let's not simplify. I know it says 2. I'll cut you a break and not write that up. If it's that hard, you won't do that on the test. That's like a box method with a foil inside of it. That's not fun. Oh, no, it's not. Wait, no, it's not. That's easy. Yeah, what happens on the inside first?
Negative 5 times 2.
5 and 1.
5 and 1 turn into what? 6 minus 5x squared. And then it's FOIL. First, outer, inner, last. So you get 36 minus 60x plus 25x squared. Okay. To do f of g of 2, you just plug 2 into x and solve for it. I know that's long to be on the calculator. F of g of 2, just plug in 2 into that. Practice at home. If you're watching this, pause the video. Practice that.
Could you just do it into the unfactored form?
You could also do it into the first problem, then plug that number into the second problem. Or not problem, but inside, outside. You could definitely plug a 2 into G. Solve. Plug it into F. Solve.
I'm talking about the 6x minus 5.
Yeah, and you should. Shouldn't you? Good thought. That'd be way easier. 6 minus 10 is negative 4 squared is 16. Much easier. That's actually easier than even the first thing, which the plug it in, solve, plug it in. All right, practice problem.
Question for 24.
Yeah, what you thinking?
Because this Socrates will assign.
Oh, frick.
Isn't that what we learned?
We did just learn it. Crap, nobody said 23. Hopefully you're what we've been doing.
Yeah.
But still, that doesn't make it easy.
Okay, 23.
No, I don't want to do it. I'm just saying it doesn't make it easy just because. No, I'm not saying hey do this problem. I'm just saying
that's gonna be on
absolutely.
Okay.
Now
Now we know.
the irrational ones aren't going to be on there. The square root and i's aren't going to be on there. Okay, Descartes' rule of signs. Hang on.
Isn't that where you just put the
Oh,
arrow?
I can't do that. I was going to pull up the test, but I'm recording, so I can't do that. No, but I was going to freeze the screen, pull up the test. But then, yeah, no, I don't want to do that.
Everybody start frozen.
Yeah. Sure. Maybe.
How many questions?
How many questions in the review? Boom. But half and half, split into 2 half, probably.
Okay,
12 and 13. If one ends up being longer, maybe that one will get shortified. If like one of them looks like it takes a long time. But okay, what's up?
This one looks really easy,
Which one?
but I don't know. I was like looking at it. That one, number 9.
Number 9?
Oh, you're just on it.
How is the graph obtained? We can just talk about that and not do it. Number 9. How is the graph obtained? It's a 2-word answer. Reflect across horizontal reflection, also known as reflecting across the y-axis. Done. Good question, though. All right, what else are we looking at?
But can you go to the piecewise function?
Yes, that will be on there, so we'll do that. Sorry to skirt the Descartes thing. I just really want to spend the last 20 minutes we have. This number 10?
Yes.
Perfect. Ooh, sketch a graph. This is fun.
Wait, it says sketch graph.
Yeah, the second half does. All right, here's the piecewise.
When it says sketch a graph,
Mhm.
we actually have like small graphs on the test.
Yes, and I'll give you numbering, and I'll make sure it all stays on the graph too. And I'll label the axes. So if it's going to get up to 24, you'll probably have a graph that goes up to 25. It'll be pretty obvious. Like nothing's going to be like messy. Here we go. But it might say sketch a graph. That's fair game. So let's just do the first one. F of -2. Where does that get funneled into? You think the top one? Why?
Because it's -2.
-2 is in fact less than or equal to 1. Oh, yeah. Boop. Sorry. Zoom in a little bit. So we funnel it into the first one because of that condition, right? Sounds good? So we go 1 minus -2 is 3. Not too bad if you know how to do it. If you forget how to do it, it's like, crap, I don't remember what to do. You funnel this 1 through.
It's the same one too.
Oh, it gets into the top one again, right? So f of 1 equals 1 minus 1, which is? That's it. I'm pretty sure if you want to look at your note card, though, the one on the test is it has 3 spots instead of 2. It's still just picking one of the 3, but it has 3 spots instead of 2. But your note card has 3 as well, because I made sure that would look a lot like it. And then it says sketch it. Here we go. Actually, hang on. XY graph. Free PDF. Sweet. Open. Oh, they're so mean. That's so mean of them. Let's find a different one. Haha. Much nicer people. Why? Why make it private? This is not like unique. Like, you're not going to make money off of that. Why make that behind a paywall? Okay. Yeah, this seems like it could be the size graph for this problem. It doesn't get much higher than 2s and 1s, right? Okay. So where is our special boundary that we need to like take into consideration? I think so, right? Something interesting happens at 1, right? We split between 2 different types of things at the number 1. So I've seen different people do different things. I just like to do a dashed line. Right? You can do a solid line, do different things. I just do a dashed line so my brain knows something's changing there. I don't know what it is yet, but something's changing there. All right, let's graph the 2 lines. Here's some practice graphing lines better than last time. I definitely did an ugly graph earlier today. Easier way to graph a line. What's the first y-intercept for the top?
1.
Let's do top is red.
Oh.
Y-intercept is 1. What's the slope? -1 over 1. So rise over run, down 1 over 1, down 1 over 1, down 1 over 1, plot it. Oh, we're done. So we go backwards. Draw that line. It's a red line. Boom. Now what happens at the red dotted vertical line? Does it include this red line or is it going to include the blue line?
It includes the blue line.
Why does it include the blue line?
It doesn't have
The blue also has.
Oh, interesting. It needs this underline, right? See that underline right there? That symbol means it includes. This symbol means it does not include, right? So the red one's going to get included and the blue one's not. But we still have to graph the blue one. So what's the y-intercept of the blue one? 1. So we draw an open circle at 1. And then what's our slope? So up 2 over 1. Up 2 over 1. Up 2 over 1. You might be thinking to yourself, we never did this. You would be 100% correct. We did not ever take a day to graph lines. I do apologize. There's just not enough time in the year. Come to office hours if you want to practice graphing lines. I will practice graphing lines happily. But that's pre this class, I believe. At least the book assumes it is. So, but if you want to practice it, freaking come to office. Yeah, that's what it looks like. Open circle, closed circle. Don't forget the closed circle at one of them. One of them better be closed, one of them better be open. They can't both be closed. Why can't they both be closed? And that would mean it's not a, that's like the exact definition of not a function. The sentence, you wouldn't know what to do, is the definition of not a function. Because if you didn't know what to do, that's not taking a number, plugging it through a system, and getting a number. That's taking a number, plugging it through a system, and getting 2 numbers. That'd be like you turning in the exact same test as someone else, unrelated, and then me giving one of you like a 90 and one of you like a 30. And you're like, that's not a function. Like, you're not, this, like, yeah, this doesn't make any sense. We gave you the same thing, and you gave us 2 different things. All right, more problems. We've got 10 minutes. We can probably get 1 or 2 more, depending on the problem.
Okay, so I have a question on.
Yeah.
It's not really like a math thing. It kind of is. So on 23, you know how A says list all possible rational zeros, and then C says.
You said 23. Sorry, I'm not there. Yeah.
And then 3 says find the zeros of P.
Uh-huh.
So on the first one, we just do like the beginning of TL.
The first one is just TCLC and all listing it out.
Okay.
Which actually, there's like 2 of them, or 6 of them. No, there's 4 of them, right? It's so short. We could do it in 2. This is a very short. At least the part A is super short, right? Probably should be super short because it's just listing out the TC over LC. So what's your TC?
3,
100%. What's your LC?
2.
So what's your possible rational zeros? Would be whatever 3 over 2 yields. What does 3 over 2 yield?
Plus or minus
Plus or minus 1.
1, plus or minus 3.
Plus or minus 1.
Plus or minus 2.
Okay. Maximum, that's like 8 things, right? It's not that many. So what are all the things that yields? Because you actually do have to list them out.
Oh, wait, we have to continue after that?
Well, you just have to list all the numbers. Because that's not numbers, there's a comma in there.
Okay,
1 is 1?
-1,
Yeah.
3, -3, -2.
Mm.
No?
I don't see a -2.
Oh,
There's a reason there's a freaking
Oh.
division sign right there.
plus or minus 3 over 2.
3 over 2, -3 over 2. You can write plus or minus and get credit. That's fine. Just not the division sign.
4 over 2.
And 1 plus or minus 1 over 2. 1 over 2, comma, -1 over 2. That's everything. You can't, I don't know. You can. I know you know what to try based on this. But if it asks you for all the possible rationals, that's all the possible rationals right there. And then you said a second later, when I asked you for the actual ones, how do you figure out which ones of those are real or are good or not? Synthetic. You just synthetic them all. If you got to do 8, do 8. I'm sorry. How many total would there be, though? 3 total, right? Straight up, 3 total. You want to throw Descartes' rule of signs in there, you could say plus, minus, minus, plus. How many sign changes are there? 2 sign changes? That means there's either 2 real positive or 0 real positive. Kind of crazy. That was the real quick sign change rule. Like the quick version of the sign change rule.
And then the last one, which is sketch the graph, it's sketch the graph of whatever you get, right? Like of the zeros that you get when you solve the problem.
Yes. Frick, let's just do this. This is a good problem. Let's just do this. Can someone just synthetic divide, grab a number? Someone grab 1, someone grab -1. We'll end with this. Grab a number, yell them out when they work. Yo, you already did it? Dang it. -1 works? So -1 breaks it down into 2, -5, 4, 3. Did they skip any numbers? 3, 2. Nope. Drop down the 2. You know, with -2. Freaking. Thank you. 7. What?
4 plus 1 was it?
I think maybe 1 works.
I don't think it works.
3 works for sure?
It works in -1.
Does -1 work?
It must have been.
Maybe it's +1. Let's try +1 real quick. It's just going to change a couple signs. 2 times 1 is 2. Turns that into 3. -3. Turns that into -3. Turns that into positive. Unless I'm writing it down wrong, which happens often. Yeah, I did write it down wrong. I'm an idiot. Thank you. Good catch. Sorry, people watching at home. You see, -1 then is probably right. 2, -1, -2, -7, 7, +3, -3, 0. You were right the first time, and I was wrong. Extra credit. Extra credit goes to Catherine for that. Okay. -1 works. So what's our function that we're left with?
2x squared.
Minus 7x plus 3. Okay, don't even keep going. You're done. What do you got to do here? Slide and divide or quadratic formula. Either one. If you want to do quadratic formula, you be a hero. If you want to do slide and divide, you do that. On this side, we've got x plus 1, right? Outside of it? Because of the x minus -1. Slide and divide is what I'm going to do. If you want to rewind this in slow-mo, feel free. Times 2, x squared minus 7x plus 6. What are the nice, neat factors of 6? X minus 6 minus 1? Oh, it worked. That's why I like slide and divide so much, because that's so much easier than the quadratic formula, to me at least. It might not be to everybody.
X equals 6.
Divide by 2. Divide by 2. X minus 3. 2x minus 1. That's the third slide, right? You've got slide, divide, slide. You've got slide, divide, slide. and still got your x plus 1 hanging out, that's the complete factorization, right? So it said, find all possible rationals. We did it. Find the complete factorization. If I duplicate this, man. We did it. Find the zeros. That's like a 1 second problem once you get this done. Right?
Yeah.
What are the zeros then if we just zoom in real big and say, oh, look, I know the zeros from that. X equals -1. X equals, looks like 1/2. Set it equal to 0 and solve if you're not that quick in your brain. That's okay. Sketch the graph takes like 2 seconds now and then we're done. Oh, we still have 3 minutes. Look, we did this in less than 8 minutes. What are the 3 points you do first?
The X is
Those zeros. -1, 3, 1/2, right? -1, 3, 1/2. What's the second thing you do?
we find out if you have to do the crossing.
Not yet. In behavior first. We do the easy stuff first. 0, that's the easiest thing because you're done. In behavior is a little harder because you have to think. But it's not that much thinking. You just look at this freaking thing and say, what does that mean for the end of this thing? It's positive, which means it's either happy or happy stock line. That looks like that to y'all. Right? Positive means it's either a happy stock or a happy face. Now, how do I know whether it's a parabola or a liney thing? Odd or even, and 3 is, so get rid of your parabola. It's a line. So we go to those dots, and you know what we draw? Looking like a happy stock line. And now we decide crossing or not. And crossing or not has everything to do with how many times each solution occurred. We'll go back to those zeros. How many times did each zero occur? You see any exponents up there? Nope. Honestly, no exponents. So it's got to be a cross, cross, cross. Right? Because and if you want to be able to label that like correctly, you would look at each of these and say m.1, m.1, m.1. What does m stand for? That's okay. It just means the crossing or not. M is that little exponent number that you would see right here. This invisible 1, that's your m. And what does m mean? Multiplicity. So cross, cross, cross. Finish your sketch, and you're done. There's probably one more thing you could do just for prosperity. You could probably go and plug in 0 and get your y-intercept. Actually, wait. You could probably get your y-intercept right away. What's your y-intercept? So you could go ahead and 3. Zoom out real quick. If you want to go home and watch this video, slow it down, please do. I'll just mark everybody here for the roll. That way you don't have to stress about it. Please go study. There's 4 hours to watch. You can practice these notes. The notes are updated right now online, so you can see this right now in this moment. Please, please, please study. If you have any questions, email me those questions.